Thank you for joining us for the 2014 SUNY Polymer Science Annual Student Conference. My name is Lindsay Kayla and I will be your host. The topic this year is thermoplastic polymers. In collaboration with the New York Department of Education, we hope to raise awareness for thermoplastics in society and their impact. We asked a few people on the street, what do you know about thermoplastic polymers? Before we go any further, let's take a look at their responses.
플라스틱같이 단단한 중합체 종류. Si je devais deviner, je dirais que c'est un type de plastique.
我觉得是一种不可循环使用的一种塑料吧。
Je ne sais. Thermo what?
Well, as you can see, most people have never heard of the word thermoplastic polymer. Hopefully that will soon change. Today we have 4 scholars here to come in and talk to us about these polymers. First, we have Dr. Lay here to give us a scientific definition of the thermoplastic polymer.
The present invention related to thermoplastic polymers, particularly to polymers of monomers comprising one or more hydro acid, and especially to polymers which are capable of being molded by hand.
Thank you, Dr. Lay. Wow, very descriptive. For those of you who didn't understand his words, we have Dr. Wong here to simplify things.
In short, thermoplastics are a type of polymer that can be reshaped when heated above a specific temperature and become solid when cooled. This reshaping process can be repeated endless times. Therefore, thermoplastic polymers are normally recyclable.
Thank you, Dr. Wong. Okay, so now you know the definition of a thermoplastic polymer. But what about thermosetting polymers? Let's take a look at a real-life example to see how these differ. Dr. Petrozewski will be taking it away.
Thank you. Instead of trying to use a complicated example, why don't I use something that everyone understands? Food. An omelet is the way to show everyone how thermoplastic polymers work and how that differs from thermosetting polymers. When you get an egg out of its shell, it's in a liquid form, and you have your cheese in a solid form. Once you put the egg in the pan, you'll see that it becomes a solid, whereas the cheese becomes a viscous liquid. Now, this is where we'll see the difference between the cheese and the egg. The egg will act as a thermosetting polymer would, such to say that the egg will now remain solid. It doesn't matter how much you heat the egg, it will always stay solid. The cheese, on the other hand, will act as a thermoplastic because after you allow the cheese to sit, it will cool off and go back to a solid. If you choose so, you can heat up the cheese again to turn it back into a viscous liquid. This is the same way a thermosetting polymer would work and the same as a thermoplastic polymer would act, except the omelet is much more delicious.
Wow, that looks great. Thank you, Dr. Petrozewski. Now that we know the difference, let's see where thermoplastic polymers are seen in today's society. Dr. Kaur is here to tell us about their uses.
Here are some common thermoplastic applications that we could find in our daily life. One of the applications is polyamide, which is also known as nylon. Polyamide is tough and has good resistance to chemicals. We could find polyamide in bearings, gear wheels, casing for power tools, hinge for small cupboards, and clothing. Next example is polymethyl methacrylate, which is also known as acrylic. It is stiff, hard, but scratch easily. It's brittle in small sections and also a good electrical insulator. This thermoplastic can always found on covers of storage boxes, signs, aircraft canopies and windows, covers for car lights, wash basin, and bath. Polypropylene is widely used in medical equipment, laboratory equipment, containers with built-in hinge, plastic seat, string, rope, and kitchen equipment. It is light but hard thermoplastic. It is also a good resistance to chemicals, however it scratches easily. Polystyrene is also another common thermoplastic application in our daily life. It is light, hard, stiff, and brittle with good water resistance. Examples of polystyrene are toys, plastic boxes, and containers. LDPE, also known as low-density polyethylene, is usually found in packaging like bottles, toys, packaging films, and bags. It is tough, flexible, and soft. It is also a good chemical resistant and electrical insulator. Lastly, HDPE, high-density polyethylene, is a hard and stiff thermoplastic found in plastic bottles, tubing, and household equipment. It has the ability to be sterilized.
Thank you, Dr. Cole. As you can see, thermoplastic polymers are all around us. Hopefully you have all learned something from today's guests. Thank you for joining us from all of us here at the 2014 SUNY Polymer Science Annual Student Conference. Good night.